Ever get into like an argument with your voice assistant? You know, you're trying to tell it something important. Maybe you're even a little heated and it just like keeps asking you to repeat yourself.
Oh, yeah, it's the worst.
Like, come on, can't you read the room?
Right. You think by now they'd be able to handle a little interruption.
Exactly.
Yeah.
And that's what makes this research you sent over so fascinating. It's about this AI model, LSLM, that can actually listen while speaking.
Yeah.
Imagine that. No more talking over each other, just like a natural back and forth like you'd have with a real person.
Yeah, it'd be amazing.
The paper's even titled, Language Model Can Listen While Speaking, Exploring the Quintessential Ability of Interruption, which I have to say sounds incredibly promising.
It really does. This is a huge leap forward.
Yeah.
Most voice assistants today are stuck in what we call simplex, or half-duplex modes of communication.
Simplex, half-duplex. Those sound a little complicated.
Not really. Think of it like this. Simplex is your classic walkie-talkie.
Okay.
One person talks, then the other, no overlapping at all.
Right.
Half-duplex is more like a phone call. You can both talk, but only one at a time. Figure 1 in the paper actually illustrates this beautifully.
Okay, so then this new LSLM model,
Yeah,
it's like the next generation, right? Full-on conversation.
absolutely. Full duplex modeling, or FDM, is the holy grail of natural speech interaction.
Okay.
And that's precisely what this research is working towards. What's really exciting is that they're not just keeping it to themselves. They've made LSLM an open source model, meaning other researchers can build on their work and push the boundaries even further.
Now, that's what I call collaboration. But how does it actually work? Is it some crazy, complex algorithm that only a handful of people understand?
It's surprisingly elegant. LSLM actually mimics the way humans process speech.
Interesting.
With a clever two-channel structure, one channel focuses on speaking, while the other is dedicated to listening in real time.
So it's like how our brains are constantly juggling speaking and listening at the same time.
Exactly.
We're forming our own thoughts while also paying attention to what the other person is saying and looking for those cues that tell us when it's our turn to talk.
Precisely. Now, the speaking channel in LSLM relies on a system called a token-based TTS system.
Okay.
Imagine it like this. Your words are broken down into smaller pieces, almost like building blocks. And then those blocks are used to generate natural-sounding speech.
Fascinating. So it's essentially learning how to construct sentences that flow naturally, like we do.
Yeah.
What about the listening side of things? How does LSLM process that incoming audio?
That's where the listening channel comes into play.
Okay.
It uses a specialized decoder to analyze the ongoing audio stream in real time,
Okay.
which is crucial for creating a truly interactive experience. If it had to stop and process everything before responding, it would feel incredibly clunky.
Right. It'd be like having a conversation with someone who pauses for 5 minutes after every sentence.
Ah,
But you mentioned two channels. How do they work together? I mean, how do you combine speaking and listening in real time without creating a jumbled mess of information? So we've got these two channels, speaking, listening, working simultaneously, but how do they actually work together without creating a jumbled mess?
it's definitely a tricky feat. The researchers explored different ways of combining these channels,
Okay.
which they call fusion methods.
Fusion methods.
They experimented with early, middle, and late fusion, essentially testing when to blend the information from the listening channel into the speaking channel's process.
Interesting.
Think of it like adding spices to a dish.
Okay.
Do you add them at the beginning, middle, or end of cooking?
Right. Makes sense. And in this case, the spice is the ability to react in real time.
Exactly, and what's fascinating is that middle fusion proved to be the most effective approach.
Interesting.
Combining the information at each step allows for these dynamic adjustments based on what's being heard. It's like LSLM is having a conversation, constantly adapting to new information, just like we do.
So it's not just waiting for its turn to speak. It's actively listening and adjusting its response as it goes.
Yeah.
It's incredible.
Yeah.
But did they test this in a realistic setting? After all, the world is full of distractions and noisy environments.
You're absolutely right. Real-world testing is key.
Yeah.
They designed two challenging scenarios: command-based FDM and voice-based FDM.
Okay.
In the command-based scenario, they tested if LSLM could recognize a specific command, like honey,
Honey.
even with background noise.
So like trying to get its attention in a crowded room.
Exactly. And in the voice-based scenario, they threw in a wider range of words and speaker variations, really pushing the boundaries of real-world conversation.
I imagine that's a lot tougher for an AI to handle.
Yeah.
Did LSLM pass the test?
It did remarkably well in the command-based tests, demonstrating an impressive ability to focus on a specific command even with distractions.
Okay.
The voice-based scenario, however, proved to be more challenging.
Yeah.
While it still performed well, the accuracy dipped slightly when dealing with greater linguistic complexity and unseen speakers.
It sounds like it's still learning, just like us. Which makes sense. Human conversation is incredibly nuanced. But it's still a huge step towards more natural interactions with AI. Is there a way to actually see how LSLM is making these real-time decisions, like peek inside its brain while it's juggling everything? It's like being able to see the gears turning inside the machine. Right?
Yes.
Is there a way to actually visualize how LSLM is making those split-second decisions?
There is. Figure 4 in the paper shows a graph that tracks the probability of an interruption token.
Okay.
It's fascinating to see how this probability spikes when LSLM detects an interruption, almost like it's saying, hold on, I hear something important.
Oh, I see. Okay, so that's how we can actually visualize it working in real time. So imagine voice assistants that actually know when you're about to chime in. Instead of making you feel like you're stuck in that endless loop of, I didn't quite get that.
Exactly.
It could completely transform how we interact with technology. This is huge.
Absolutely. We're talking about a future where AI seamlessly integrates into our lives, where conversations with machines feel just as natural as those with another human being.
Yeah.
Think about the possibilities for customer service, education, even entertainment. The applications are incredibly vast.
It's like we're on the verge of a whole new era of communication, which is really exciting.
Yeah.
But as with any major technological advancement, there are bound to be some challenges as this technology evolves. What are some of the hurdles that the researchers still need to address? What are they looking at next?
Well, one of the big ones is language.
Okay.
Right now, LSLM is primarily focused on English. Adapting it to other languages with their unique rhythms and conversational structures will be key to making it universally accessible.
Right, because what might be considered a polite interruption in one culture could be interpreted very differently in another.
Exactly.
So it's about understanding those subtle nuances of human interaction.
Exactly. And while this research marks a significant step towards more natural AI interaction, it's important to remember that we're still in the early stages.
Right.
Think about how far voice assistants have come in just the past few years. This technology is evolving rapidly.
Yeah, it really is.
And with continued research and development, the possibilities are incredibly exciting.
It really is amazing to think how quickly things are progressing. So to close us out, what would you say to our listener out there about where we go from here?
You know, it makes you really think what the future holds. As we move towards a world where AI can seamlessly join our conversations, where will it take us?
Yeah.
Will it break down barriers and foster deeper connections, or will it blur the lines between human and machine in ways we haven't even imagined?
Right.
Only time will tell, but one thing is for sure. The future of communication is about to get a whole lot more interesting.
It really is. And on that note, we'll wrap up another deep dive.